In this lesson, we're going to talk about different types of numbers. So this is your 1-3 notes. This is page 6 in your binder, so get that set of notes out. The first set of numbers we're going to talk about are called natural numbers. Sometimes we call these whole numbers. Natural numbers are your counting numbers. They're your numbers that you count by when you count numbers. When you were younger, when you were little and you started learning to count, you counted 1, 2, 3, 4. Those are your natural numbers. Natural numbers are whole and positive. So all natural numbers are whole numbers. That means no decimals, no fractions, and they're positive numbers, no negatives. So some examples are 0, 1, 2, 3. Write out a couple more examples here. Those are natural numbers. We use the letter N to represent natural numbers. Next are integers. We use the letter Z for integers. Integers are all of the natural numbers, so all of these numbers, and their opposites. So 2 is a natural number. That means it's also an integer. But also its opposite is an integer. -2 is an integer. Integers cannot be fractions or decimals. So natural numbers can't be fractions or decimals or negative. Integers can be negative, but still not fractions or decimals. So a couple of examples would be like -3, -7, 0, 14, any negative number or positive number as long as it is not a fraction or a decimal. Give yourself a couple of more examples there. The next set of numbers are rational numbers, which we use the letter Q. Rational numbers are all of the integers, so all of these numbers up here, as well as any fraction, so every single fraction, or any decimal that ends, or a decimal that repeats. So if the decimal does not end and it does not repeat, it is not a rational number. If it's not a decimal at all, like 14 back up here, that's an integer. Rational numbers are all the integers. So 14 is a rational number. Every single fraction is a rational number. All rational numbers can be written as a fraction. So even if it's not a fraction, there would be a way to turn it into a fraction. Like -7 is -7 over 1. 0.5 is the same as 1/2. 0.333333 repeating forever is the same as 1/3. So every rational number can be written as a fraction. A couple of examples. 12, because 12 is an integer, so it makes it rational. 12 is also a natural number. -3, once again, it's an integer, so it's rational. 16.278, because that decimal ends, 0.278, and then it stops. -20.56 with this bar over top, which means repeating. Negative 20.5656565656. That is a decimal that repeats. That makes it rational. 21 over 11. That's a fraction, so it's rational. See if you can give yourself a couple more examples there. The next set are our irrational numbers. Irrational numbers are all of the non-rational. That means every number is either rational or irrational. It can fit into one of those two categories. If it's rational, it cannot be irrational. If it is irrational, it cannot be rational. So because 12 is rational, it is not irrational. Irrational numbers are decimals that never end or repeat. They go on and on and on forever without any type of an ending or a pattern. Irrational numbers cannot be written as a fraction. That's pretty much the difference between rational and irrational. Any rational number, you could take it and turn it into a fraction. An irrational number, you can't turn it into a fraction. A very famous irrational number is pi. 3.1415, blah, 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 on and on and on forever. Another example would just be a number like 6.73276104, and then it goes on and on forever. When it has these dots at the end, lets you know it's going to continue forever, and you see how you don't notice a pattern? It means there's no pattern to it, it's not repeating, and it's not ending. That is irrational. A lot of square roots are irrational. Not every square root number, but a lot of them. The square root of 2 is an irrational number. You can go to Desmos and type in the square root of 2, and you're going to see that it's a non-ending, non-repeating decimal. Anytime you have a square root number, using Desmos would be useful to you to see if it's irrational or if it's rational. And then the last set we're going to talk about are real numbers. Real numbers are all of the numbers on the continuous number line with no gaps. Every decimal expansion is a real number. Real numbers can be rational or irrational. Every number in our class is real. There are such things as non-real numbers. You don't need to worry about those in Algebra 1. You will learn about them later. Every number in our class is real. So if I ask you if some number is real, you are going to say yes, because every number in our class is real. Now I want you to flip this paper over. Now, you want to know that if you know a number is natural, that means it must also be an integer. If a number is an integer, it must also be rational. A number is rational or irrational. And every number is real. So any number I give you, you can use this to help you. If I give you a number and I tell you -7, I know that -7 is an integer. That means it must be rational and it's also real. So -7 is an integer, rational, and real. If I give you the number pi, You know that pi is irrational. That tells you it is real. If I give you the number 2/7, that's a fraction, which means it's rational, so it's real. You can't go up. See how my arrows are pointing down and not up? 2/7 means I can't go upwards. Okay? So whatever you know it is, it's then the next things down following your arrows.